All right, so this next video is from section 3.3 now, and we're going to look at two basic rules. One's an addition rule and one's a multiplication rule. And then we're going to look at some ways that we can think about them when we add in some of the concepts that we've been working with in probability. So let's take a look at a problem and let's talk about this problem, and then we're going to talk about this addition rule. Okay, so let's suppose that you have a flower store, and in your flower store you have the following following flowers with the number of each kind of flower in parentheses. So we have 15 red roses, 10 blue roses, 13 white roses, 27 white tulips, 20 yellow tulips, 18 red tulips, 10 white daisies, 15 yellow daisies, and 17 red daisies. Okay? So that's basically the breakdown. If we imagine, we can even, in fact, create a frequency table if we wanted to. So suppose that we wanted to know the probability of red or a rose. So what I know here is that anything that has the quality of being red, okay, or anything that has the quality of being a rose, all right, is actually going to be included inside of my set. So that's going to be part of my desired results. So the first thing that I want to do is I actually want to total these. So I'm going to take 15 plus 10 plus 13 plus 27 plus 20 plus 18 plus 10 plus 15 plus 17. Oh, that's too much. All right, 15 plus 10 is 25 plus 13 is 38. It's 38 plus 27 is 65 plus 20 is 85 plus 18 is 103 plus 10 is 113 plus 15 is 128 plus 17 is 145. So we know now that what we have is we have a total of 145 total roses or total flowers. Total of 145 flowers. And what I'm going to do is I'm going to set up my sample space. Okay, I'm going to set it up as a Venn diagram to help us kind of understand this probability rule, the addition rule for probability. So on the one hand, we have all the different flowers. Okay, here's the flower shop, flowers that are in the flower shop. Okay, and so we have yellow tulips. So these are the red flowers, and here are the roses. Okay, so things like red roses, that's going to go in the intersection because that's both red and a rose. All right. Then we have blue roses. They'll go in the roses. All right. By the way, there are 15 red roses. Blue roses, we've got 10 of those guys. White roses, we have 13 of them. Then we have white tulips. They're neither. White tulips. We got 27 of those. Yellow tulips. There's 20 of them. Red tulips. Oh, those are in the red grouping. That's 18. Okay. And then we have white daisies. Neither. Yellow daisies. They're also neither. And then we have the red daisies. Okay. And there are 17 of them. So if I looked at, and I wanted to total things up, how many red flowers did I have? Well, I have 18 plus 17 plus 15. So that's 50. I have 50 different red flowers. And how many roses do I have? Okay. I have 10, 25, 38. I have 38 roses. Okay. All right. We got to do that just by adding them up in our list. But I kind of wanted to show you what the Venn diagram was going to look like. So in the red roses, you want to notice that what are the things that are in the red roses? We have red tulips. We have red daisies. Okay, and we have red roses. And then in our roses group, we have the red roses, the blue roses, and the white roses. Now what I want you to notice is that there are two elements that are actually in both. The red roses are in both of the groupings. And what that means is that they're included in the count for red flowers and also for the roses, right? So if we add them up, 50 plus 38, that's going to equal 88, right? That's 50 plus 38, it's 88. But the problem is that we've added in the roses twice. So it's actually not going to be 88. Let's take a look. Our actual count is going to be 18 for the red tulips, plus 17 for the red daisies, plus 15 for the red roses, plus 10 for the blue roses, plus 13, okay? So that's going to end up giving me 18 plus 17 is 35, plus 15 is 50, plus 10 is 60, and it's 73, okay? So when I added them up individually, I got 73, and when I added them up as groups, as red and roses, I got 88. What's the difference? You'll notice, right, that the difference is actually 88 minus 15 is going to give us 73, right? So these two would be the same if I actually subtracted out the 15, which just so happens to be the red roses. The reason why we get that difference in those two numbers, why the 50 plus the 38, that's my red plus my roses, right, is different from adding up all of the individual groups together, is because what we have here is we have a double counting. We've counted the red roses twice. We counted them in the red group and we counted them in the rose group, okay? And so that thought that we're going to be double counting becomes a really important fact when we're doing additions of probabilities, okay? So let's actually take a look at this. Let's say, for example, I want the probability of red or the probability of a rose, okay? Now, I'm going to actually account for, right, rather than going through and adding them all individually, because sometimes you don't have that information, I'm going to write that. That's going to be the probability of red, okay, plus the probability of rose, and then I'm going to subtract out the double counted probability of red and a rose, right? Those are the red roses. So, and we can kind of see in terms of our totals, red was 50 out of 145, plus probability of a rose, that's 38 out of 145, and then we're going to subtract 15 out of 145. And so you can actually see, if we just, remember adding fractions, 50 plus 38 minus 15, that's 73 out of our 145, right? Which is exactly what we should expect if so 73 out of 145, and that's 0.503. And that's exactly what we should expect if we went through and we counted them individually. So that actually leads us to our addition rule. Our addition rule is that we have two events, A and B. The probability of A or B, which we can also write as A union B, is going to equal the probability of A plus the probability of B minus the probability of A intersect B, or A and B, okay, which is probability of A and B. Okay, and so what that means, that's exactly what we just did right here. Let's do a quick example, okay? Suppose that we have 30 students in the class, or let's just say we have students in the class, because where this is going to really come in handy is when we don't have actual counts and instead we just have probabilities. The probability that a student is on financial aid is 0.67, okay? The probability that a student studies humanities is 0.39. The probability that a student, and you know what, I'm just going to write this, P, that a student is on financial aid and is in the humanities, that is that they have both, is going to equal 0.21. What is the probability that an individual is in financial aid, has financial aid, or is in the humanities? And so we're going to use our formula, okay? So I'm going to write it. It's going to be the probability of financial aid plus the probability that they're in the humanities minus the probability that they are in financial aid and the humanities to account for that double counting. And that equals, we just replace our numbers, right? Financial aid, 0.67. Humanities, 0.39. And then minus 0.21. Okay? So 0.67 plus 0.39 minus 0.21. Okay? That is that equals 0.85. And there we go. Probability of the one plus probability of the other minus their overlap. And that actually ends up giving you the probability for our union or the OR. And that's the addition rule.